So let's hop into problem number 2. One of the rides at an amusement park falls freely for 1.5 seconds after starting from rest. A. What is its velocity at the end of the 1.5 seconds? B. How far does it fall? Okay, so let's just reread this. We have a amusement park ride. It's falling freely for 1.5 seconds after starting from rest. Oh wow, that's the only information we have right now. So let's do our diagram. So we have an object. What is it doing? It's falling to the ground. I could actually just do these tick marks right here that indicate that that's the ground. And what is it doing? This is the object's trajectory, and it is just falling. We're not given the initial height of this object, and we don't even know that the final height is 0. Okay, so it doesn't say that the object hits the ground, right? Oh boy. Okay, so what we could actually say here is this. Perspective number 2, we could say that the initial height is 0, and it's asking how far does it fall. So once again, I looked at this this is perspective 1 where you are given initial height. Perspective 2 where you're not given an initial height. You could just actually define that the initial height is 0 and it's going to fall for a certain amount. This will now be a negative number. Okay, so our initial height is going to be 0. Final height is what we're trying to find. Initial velocity. Hey, are we throwing this object up or are we throwing it down? No, it's saying that it's freely going to be falling. So the initial velocity is going to be 0 meters per second. First question asks, what is its velocity at the end of the 1.5 seconds? Oh, so we're actually going to be finding not just one thing, but we're going to be finding 2. And once again, what is the acceleration of this freely falling object? Negative 9.8 meters per second squared. That's acceleration due to gravity. And our time here is 1.5 seconds. Okay, so once again, we're going to be finding 2 things. So let's find the final velocity first. So if we're trying to find this, what we're going to do here is say, hey, you know what? I don't care what our final height is. So this is going to be the thing that we don't care about first. And then when we're trying to find out the final height, what we're going to say is, hey, you know what? I don't care about what this is equal to. And that's the way that we're going to be determining which equations to be using. So to find our final velocity, we're going to say to ourselves, I don't care what the final height is of the object. I'm just going to erase this diagram. Okay, so coming over here. Okay, so where do we have final? Oh, so do we have final height over here? YF? No. Okay. We have YF over here. So I'm going to say I don't care about this one. We have YF right over here. So I'm going to say I don't care about this one. And we have YF right here. So these ones won't help us out finding our final velocity, but this one will. So let's write that down. Okay, so that will help us finding out our final velocity. So let's do that first. Let's just plug this in and go from there, okay? So VF is equal to VI, which is 0, plus our negative 9.8 times our time, which is 1.5. And when we plug this into our calculator, we see that this 0 provides no value, so we can get rid of this. We have a positive, we have a negative 9.8 times a positive 1.5. Will that result in a negative answer? And when we plug this in the calculator, we will get our answer of 14.7 meters per second. What does that negative represent? The idea that the object is being dropped. And we know that velocities are vectors, so therefore it does have to do with both a magnitude and our direction. Okay, well, that's for VF, so we just did that. Problem A is done. What about problem B? How far does it fall? Okay, so we want to find out what our final height is going to be. So therefore, let's not include this answer when we're trying to calculate this out. We're going to say that we don't care about this right now. We could use this answer, but the thing is though, is that I don't want to use something that we calculated in order to calculate out the next step. I'd rather just use our given information. If we got this wrong, if we actually did anything wrong here, if we forgot to include our negative here, we will get this answer wrong right here. So therefore, I don't want to use this VF value. So coming into here. Okay, so we're just going to go through this right now and say the values that we don't care about is VF. So coming through here, we have VF right there. That's not going to help us find our final height. This over here, we have VF right there. Don't care about this one. VF. Oh, we don't have VF in here, but we do have VF over here. Process of elimination is great, and there we go. So we're just going to use equation number 5. Make sure that you actually write this all correct. A common mistake that I do see with this equation is forgetting this squared right here. Okay, so we have our formula. Once again, just double check to see that you have the formula written out correct. And I believe that we do. So once again, we're trying to find out what our YF is equal to. One thing that's great is that it's already solved out for YF. So once we actually plug in these numbers right here, we could just toss this in the calculator and get our answer. Okay, so we have this 0 over here. That's not going to provide any sort of value. And we have 0 times 1.5. You know what? That's not going to provide any value whatsoever. So we have this positive 1/2 times a negative 9.8 times 1.5 squared. Hey, so this negative times the positives will actually result in a negative answer. So we have our YF. Tossing this in the calculator, we will get our answer of 11.03 meters, and we should be including the negative here, being that that's how much it drops. So I should really just include that in there as well. So that's how far this object drops. We do, so thinking about this once again, we have an amusement park ride that's freely falling for 1.5 seconds. How far does it fall? It falls 11.3 meters.